APA Math kiddos, we are going to go on our first flipped classroom journey together. And right now we're going to have the presentation. I want to remind you, for those that weren't here, that we're doing testing or makeup testing, that we are going to focus on a flipped classroom idea which centers around these components. The first thing that you need to do is you need to watch this video. When you watch these videos, you need to take notes, because in the first session, there's going to be a bunch of check questions about this video, where I'll ask you certain things that you will only know if you take notes and you listen. Please pause this video at any time, and we'll kind of go on. All right, let's go ahead and go to the lesson. Let's go ahead and click on the lesson. This is Flip Classroom. We're going to click on this, and I'm going to go ahead and present it. I am joined here with the lovely... All right, Dorothy, you're going to help me out, right?
Yeah.
We also have a random child in the room taking a random test that's not making any noise. So don't mind them. What are we doing, Dorothy?
Today we're doing
Okay, so you've seen something like this before, right? What does that mean? Straight line, like this, right? Nope, that would be half the class's line. I like it straight with a straight edge and ruler. Okay? No sloppiness. Can you think of someone that's sloppy in our class? Don't say any names. All right, so let's go on. And then the next word that we have right here is inequalities. When's the last time you saw it? When's the last time you did something with inequalities? You don't remember. Well, hopefully we can refresh your memory. All right, so linear inequalities, if you want to go ahead and read this portion. I'm not going to talk too much about it. This makes it, the rest of it seems kind of cooler and more. But in essence, you're going to see something where there's an equation with a y and an x in there, with an inequality. Are you used to seeing a y and an x with it, or not? That is correct. Normally we're used to seeing stuff where, actually let's go backwards, and I'll go ahead and switch screen. We're normally used to seeing stuff like right? Or something like x plus 3 is less than 1. And then how would I solve the second? Right? Or do you want me to just write for you?
Right.
Okay, I'll write.
So to solve the second one, you're gonna have to make x alone, which is your goal. So you're gonna subtract 3 from both sides.
Fantastic.
And that would be x is less than or equal to 6.
Less or equal to 6. And then some strange person might have even asked you to graph it, right? And do you remember how to graph it? Let's not worry about the top one because it could be distracting. Those people are whoop whoop with my cool sound effects.
So to graph, since it's less than or equal to, it's going to be a closed circle where the 6 is, and then you're going to do the x going the other way.
Awesome. I love it. So that means, to kind of refresh our memories, this greater than or less than or equal to and greater than or equal to, what symbol do we use?
Closed circle.
Okay. A closed circle means filled in. A lot of times we say it's also included. And then and then less than or greater than is going to be. Now this refers to just a one variable situation. Now we're going to go into what we call a two variable situation. Okay? In the two variable situation, what we say is that it's going to be if it's less than or equal to or greater than or equal to, we call it a solid line. Okay? Much like it being filled in, the solid line is just filled in. There's nothing that's blank in there. Whereas with a two-variable equation, we have what we call a dotted line. And this will make more sense when we do it, but that's probably something that we have to take note of. Hint, hint. I wonder what that means. Dorky Dorothy?
I think I know what it means.
Good. What does a dork mean, Dorothy?
I don't know.
Interesting. Using words we don't know. All right, Dorothy. So let's go to the first problem. Example number 1. What does it say?
It says, is the ordered pair part of, does the ordered pair make it a solution?
Okay, so what do you mean? What ordered pair are we referring to?
The A, because that's the first one.
You see that right there, right? And what are they really asking us to do? Confusion.
Kind of put it into the inequality to see.
Put it into the inequality. Okay, so let's do it.
Okay. So first we'd have to substitute first. So 2 is y, so it would be 2 is greater than 1 minus 3. Then 1 minus 3 is obviously negative 2. So 2 is greater than negative 2. And would that be correct? And yeah, it is.
That is correct. So you would say yes. Right?
Mm-hmm.
Okay. And moving on.
So you do the same thing with the next two. So you have to put negative 3 for x, so it would be negative 7 for y. So negative 7 is greater than negative 3 minus 3. And so that would be negative 7 is greater than negative 6. And that would not be correct because negative 6 is actually greater than negative 7.
Okay. Careful. The negatives make a difference, so good catch on that, Dorothy.
Mm-hmm.
Go ahead and try out the got it right now. You don't have to worry about part B. I just want you guys to go ahead and work on this particular problem, find out the answer, and then we will make sure it's right tomorrow. All right, Dorothy, you remember we were just talking about the open circle, closed circle stuff?
Yeah.
Now check it out. The difference between these two answers when you talk about, and the only difference is the fact that now we're calling it linear.
Uh-huh.
Okay? When it's linear, this is what it looks like, because we're dealing with lines.
Okay.
All right? So in this particular problem right here, you see that, hey, we're just shading a direction. But this one, what do you notice about the line?
It's going up. And
It is a vertical line, right? But what else do you notice about the nature of the line?
it's dotted.
It is dotted. Remember we talked about how an open circle and dotted mean the same thing?
Uh-huh.
So that's what the line is. And the next part is you're no longer shading just one line. You're shading an entire
Area of it.
You're shading an entire area. Okay? Now, how do I know what side to shade? Do you any guesses?
I think I do.
What's the guess?
It's because it's less than. So it's x is less than 1 and 1. The line is on 1, so everything before 1 would have to be shaded.
Okay. Now it's very tempting to focus only on the x coordinate, but I want to caution you guys. When we deal with linears, you have to remember there's an x and a y. I would always encourage you guys to test a coordinate. To test a coordinate, you can test any coordinate to make sure it fits in. So the coordinate that's the easiest to test is always the
0, 0.
0, 0 origin. Fantastic. What I mean by that is, just like what you did in the last problem, we're seeing if you're identifying the answer as part of the solution. So you're going to plug that into the equation, and you might be wondering, what about the y? What do we do with the y?
You leave it blank.
You leave it blank. Good guess. Okay, so it would be 0 is less than 1. Is that a true statement?
It is.
So if it is a true statement, then you must shade the side with the 0, 0.
Okay.
Okay? Let's say it was false. Then you would shade
The
the opposite side. Some people do start memorizing, what direction to shade. I would advise against that simply because you're not doing something mathematical. You're just kind of coming off the shortcut. If you want to go about a shortcut, you may, but I am not going to teach it.
So this slide is pretty much showing what it's just giving you definitions. And so when it says each point on a dashed boundary line is not a solution, I believe that's showing how it's just the opposite of the solid line. So each point on a solid boundary is a solution. I think that's what it's.
That's correct. Okay. So back in the days when you were doing the number line, right? On that number line, which I'm drawing right here, if I had something like 5 and it was something like x is greater than or equal to 5, is 5 included?
Yes.
It is included, and then we shade that way. So 5 is a number that is included. Now that would be reflective, this equation would be reflective of something like this. Meaning all the coordinates, including, let's say that one right there, is what? 2, 0. That coordinate is actually on the line, therefore it is included.
Okay.
Whereas if it was dotted, what's that coordinate right there? I kind of botched it, but
I can't really tell.
0, 1, I think,
Okay.
right?
Yeah.
Is that part of the solution?
That is not part of the
It is
solution.
not. That line is not included. Okay. Everything else past the line right here
is included,
but not on the line. Okay, so conceptually that's what it means. Whoops. Last time we did example number 1, so Mr. Lowe went ahead and wrote down this is example number 2. That was a mistake. Hopefully I'll fix that before you guys watch it. All right, so graphing. You love graphing?
No.
So, do you remember, Dorothy, what we need to do when we graph?
We need to find out the y equals mx plus b formula.
Oh, y equal to mx plus b. I like how you said that it's almost as if you kind of forget about the inequality, right?
Yeah.
I would actually encourage that. Forget about the inequality. And how many coordinates does Mr. Lowe want?
He wants minimum of 3.
Minimum of 3. If you want to go for 5 and be an all-star, knock yourself out. But if we go ahead and do this, let's say if it's -1, 0, and let's go 1. Easy enough? If it's -1, any ideas?
So that would be negative. It's a 1. Yeah, mine would be 1, right?
It would be 1. I hesitated and that made you nervous.
Okay.
And 0 is?
3.
And 1 is?
5.
5. Go ahead and graph it. -1. 1 is right here. 0, 3 is our intercept. And 1, 5er. Okay. Now I got the line set up. The next thing is now we have to pay attention to the nature of the graph. Now, most people would just go ahead and graph the line. I'll see if my tool kind of helps me out. Bam. Okay, that's relatively good. Uh-oh, what did I not do?
Use a straight edge.
But my line is awesome.
Oh, you forgot it. You forgot about the inequality sign.
What is it supposed to be? What kind of line?
It's supposed to be a dotted line.
It's dotted. So a lot of people, they draw the line and they mess that up. But if the easiest thing would be to, if you were using a ruler and then you went against the ruler and you just kind of dotted it, dashed it like that. That's perfect. How if you mess that up, the simple thing is don't erase the whole line. Just take an eraser. See what I'm doing right there?
Yep.
I'm just kind of erasing parts of it like this. And now it looks dotted. Wonderbar. And I got rid of my screen too early, and Dorothy didn't say anything.
Sorry.
Shading. So the next part is the actual shading. Dorothy, you remember what we did last time when we talked about shading?
Yeah, we have to figure out if since the solution is less than y, we have to figure out what way it has to go on.
Mr. Lowe calls it the testing of the point.
Okay.
Just the test point. Okay, I totally ignored what you said right there.
Okay.
The test point, so what do we got to do?
We gotta
What's the easiest test point?
0, 0.
All right. I didn't give you the answer. 0, 0. So you would test it by putting it into the equation. Ready?
0 plus 3.
You're so fast.
I know.
Is 0 less than 3?
It is.
So you have to shade the side with the origin, which would have been... Oh, the answer's in the next slide. There we go. Right?
Yeah.
So you see how the origin is included, and by simply like, hey, the origin's right there, and it's happy. And we're included right there. All right, let's go on to the next example. This slide kind of says the same stuff in case if you read it, that means you weren't paying attention before. And this one, graphing an inequality with 2 variables. That's another sample. I want you to try it out. Have it in your notebook, okay? I'm not going to kind of stop for the video for this. And then you'll see even the answer is shown as such. Just to get some good practice. It's kind of like the got it, okay? Hopefully you paused it. Otherwise, I want you to make sure you understand how to do this. Also want you guys to try the got it's. Have it in your graphs. I may check for some I might even consider doing some notebook checks while some people are doing the questions that they're answering for more points. And let's go to example number 3. So this was officially the number 3 one. And I want to point out, what do you notice about both lines?
There's only one variable.
There is only one variable, right? So, and there's only one variable. Guess what kind of line it's going to be?
I don't know.
Okay.
Straight, vertical line or horizontal line.
Yes, it's going to be horizontal or vertical. Okay. Let's see if we'll pause for a second to try it out, or maybe you need to be working on the got it's. Pause now. Dorothy, that's amazing.
Oh, thank you.
Oh, there we go. And you wrote that down. I love the fact that you knew that all the ones were -1. Now, how'd you know that?
Because all the x's are
always right?
one.
Now, the key thing was to understand that, hey, remember we said that we want to graph it as if it was x equal to -1. Forget about the absolute value, and then put it back in as far as what the graph and then we'll go ahead and jump to the answers. Hopefully you tried it out. Those of you guys that kind of cheated to go the answers, shame on you. All right. And then you see that the answer is there. And you see that they also test the point. So follow the rules. Oh, it is 3:44, and someone just commented on how the presentation is not online yet.
Oopsies.
Oopsies indeed. It's Krish. Something that Krish would do.
Probably.
Try it out and make sure that's in your notebook, because we might be able to do that. I want to remind you that you can use your graphing sheets that I supplied with you and then just cut and paste them. Just be organized. Pause it here. Finally, we have a word, the last part, and it looks like our lesson is going to be less than 20 minutes long, which is good. The key thing is I'm going to have Miss Dorothy here read it out loud for us.
An interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone as shown. The owners can spend $420 or less. Write a linear inequality and graph the solutions. What are these possible prices for the wallpaper and tiles?
All right, so we got two things to consider, right? We know that technically with linear you have an X and a Y. Just like what you've been brainwashed with the systems, you must establish what they mean. What do you want them to mean?
The X can be the tiled area.
Amazing. Your head just came up with the random solution that's already on the board.
Thank you.
Yeah. Very smart. Too bad I don't have a real Dorothy. So now we have problems like this, right?
Yeah.
Where they established the thing, the variables are established right here, and then they went ahead and established the equation. Why would we isolate the y? Why do we like this format here?
Because the Y will
Because we like the slope-intercept from the best, right?
be
And then when we graphed it, hopefully we know. What do you notice about this graph, how it's different from all the other ones? It's not 4 quadrants. You gotta speak up. It's only quadrant number 1, because we're only interested in the positive values, especially when it involves money. And 9 out of 10 times, when we talk about being within a budget, it's always going to be shaded underneath, because that's how much we can work with. So we'll talk about using real-life math in real-life context. Okay? The next thing is considering doing this problem right now. I want you to pause this. Actually, this is the last one, so kids, I want you to do this problem, and then come class time, we'll have more time to review. This is Mr. Lowe and Dorky Dorothy signing off. See you tomorrow.